So we're starting on the review today. Zoom in a little bit for that one. Remember that each of these review questions are like one of the test questions. However, they are not identical, so you've got to make sure you read like numbers and stuff like that change. We don't want you to just pick the same one on the review automatically. Make sure you read carefully, but the review will help you set up problems the same way. So this one says, which graph represents a function where the domain is all real numbers greater than or equal to -2 and less than 7? Okay, so domain, remember, is that your x or your y's? Yeah, it's x's. So, okay, you cannot see that. I really don't understand what's going on with my camera. I apologize to you guys, because on paper that's nice and dark. You can see everything. But for some reason, okay, so domain is your x's, okay, and it says that it needs to be more, greater than or equal to -2, but less than 7. So on the x-axis, here's -2, here's 7, here's -2, 7 will be over here, here's -2, 7 will be over here, here's -2, and 7 would be way over here. So which is the one that's between those two numbers?
It would be
Yeah. Now, if we had two answers that were both between them, then you'd want to pay attention to the fact that this one said or equal to. That means this dot's colored in, but this one doesn't say or equal to, so this dot's open. We talked about open and closed dots earlier in the year when we first started talking about domain and range. But in this case, that was the only one that was between the same numbers, so that didn't matter that much. But just for the record, if you had two that were between it, make sure you would pay attention to whether the endpoints were colored in or not. They're colored in when they have the equal. They're not colored in when you don't have equal. Okay? So, again, I'm sorry about whatever is happening with the way this looks. I don't have a good explanation, but we're going to go to the second one. This one says, what's the domain and range of this quadratic function? So, I'm going to start with the question that I answered for y'all in the very first set of notes. If you have arrows at the end of your quadratic, what's the domain always going to be? It was in the notes that we filled out together. I will pull those up real quick so you can see. It was this very first page of notes that said characteristics of quadratic functions, but all of our tables right here, and I know that because of whatever's happening with the weird lighting, you can only see part of these, but domain, all real numbers, domain, all real numbers, domain, all real numbers, domain, all real numbers. So remember, I told y'all that as long as, unlike the previous problem, there's the arrows on the end, implying it keeps going and we're not just looking at a part like the top problem, it's always all real numbers. Remember, that symbol means all real numbers. Okay? That's the domain, all real numbers. So the range, though, remember the range, that's the one where you look at either your highest or your lowest point, depending on which way it's facing. In this case, we have a top. We have a highest, right? What point is, or what number is this touching on the y-axis?
that would be 3.
It would. So range is your y's, and we know that it's going to be related to the 3. Now, is everything below 3 or above 3? Below. So we put less than or equal to. And I say or equal to because it is actually touching right here. Remember, if it was open in the other way where you had the U, it would have been a greater than. And whatever the vertex is touching on the y-axis, that's what the number is. So I'm sorry this is so light. I can't speak today. Y is less than or equal to 3. Try to make that a little darker there. because I'm not sure what's happening with our camera. Okay, questions on that one? No? All right. This part is a little light too. It says all real numbers. The domain was all real numbers. That's the symbol for it. It's like a capital R, but it has an extra line. There's no rhyme or reason to what's happening. You were right. The light now seems better, but I don't know why. Okay. I'm just going to go ahead and go with maybe it's the weather. All right. It says the graph of f of x equals 6x squared minus 11x plus 3 is shown. What are the zeros? Okay, this could be a hard question, but it's really a vocabulary question. Because if you remember that zeros are also called roots, they're also called x-intercepts, and they're also called solutions. Remember those 4 words we said basically are asking the same thing. It's where does it cross on the x-axis. So if you look, it's crossing here, and it's crossing here. Those are not at whole numbers, but this one is between 0 and 1, so I would say maybe at a half. Now this is just us estimating it here from the graph. So when you have your actual test problem, make sure that you, even if you thought it was a half, maybe a half isn't going to be an answer choice, but maybe a third was. We just know that this one's between 0 and 1, and this one's between 1 and 2. So I'm going to say 3 halves, or 1 1/2, however you want to write it. You know, this could be written as a decimal. They're the same thing. And like I said, this is just an estimation. They're not going to have 2 that are so close you can't tell the difference between them. You know? So I'm not guaranteeing that this exact picture would have a half as an answer, but it would be close. Do you see what I mean? It kind of sounded like a harder problem, but if you know what that word means, it's an easy problem. So don't forget, they might call it roots, they might call it x-intercepts, they might call it solutions, or they might call it zeros. No matter what, they're asking you where it's crossing the x-axis. Okay? Or when y is 0, what is it? Okay, now the sun's coming out, making our room light up different again. The board, at least we can still see. I don't know what was happening before. It was weird. All right, questions on this one? You got it written down? Still writing, Jason?
Yes, ma'am.
Okay. All right, number 4 says the table shows some ordered pairs that belong to quadratic function h. What is the domain of h? So remember, domain is your x values. Range would be your y values, which would have been these right here. So if you're looking at these are just certain points, right? A quadratic function is a curve. So we know there's more points, so don't just list these. But what's the, okay, that's not the right way to say it. If you're looking here, we start out negative, and then we're getting bigger, right? Yeah? Well, if I have negatives, I have positives. What did we say the domain always is of a quadratic function? Yeah, all real numbers. Now, if I asked for the range, that would be different, because the range is not going to be all real numbers. It would be like y is greater than and equal to, or y is less than or equal to, whatever the minimum or maximum was. Just whichever way it's facing, but this one's not bad. But like if we were looking at the range, notice we have a big number, right? Then we're getting smaller and smaller and smaller. But then right here, don't we start getting bigger again? So if we were looking at the range, we would be like, oh, it's got to be bigger than or equal to this number, because that's where we switch directions. But always pay attention to whether they're asking for domain or range, because they're not the same thing. All right, 5 says, use the table to find the solution to the quadratic equation. So we just talked about solution a minute ago was the same as root, 0, or x-intercept, right? On number 3, we just talked about that. So it's called a 0 for a reason. But you got to be careful because there's a 0 here and there's a 0 here, right? They're not both answers. X-intercepts have an x value, but y is 0. So which one of these has y be 0? Which one of the points that contains a 0 has y 0?
That would be on the right side?
Yeah.
Right here?
Yep. So then the solution is -2, 0, or you could write that as x equals -2. Same thing. And how you know which way to put it in, like whether you put it as a point or just an x value, just depends on the situation of the problem. You'll be able to tell by looking at the answer choices which way they wanted it. Okay. Had they asked for the y-intercept, it would have been this one. Because remember, where it crosses the y-axis, x is 0. Okay. Questions on that one? Okay, well, we're halfway done with the review because that was question 5 and there's only 10 questions, so we'll move to 6 now. All right. The graph models the area in square feet of a rectangular porch with a length that is 0.56 W less than 28 feet, given a width of W feet. That's a little confusing, huh? But the question isn't. It says, based on the graph, what's the greatest area? Okay, well, look. This down here is width. This over here is area. So they asked for greatest area, so we're going to look at this side. And greatest, y'all know what greatest means. So even though the part up here is a little confusing, like just the wording of it, the greatest area would be right here where it's the tallest, right? So what value is that?
350.
So the greatest area is 350 feet squared. Now, just out of curiosity, how wide would your porch have to be to have that greatest area? Look at the width at the peak. So here's the peak, where it's the tallest, right? What's the width? So you drop down.
25?
Yeah. So just kind of point that out. They can use the same picture and ask different questions. They could say what width gives the biggest area. And then 350 wouldn't be the answer. 25 would be. Or whatever numbers are there. Doesn't have to be those numbers. So do y'all see how that's a good example of sometimes a question sounds like a hard question, but it's really not? Because when I read that first sentence, I don't know about you, but even me, who is good at math, but I have to break it down and think about it, I was like, what are they even saying? What are they asking? But if you keep going, always read the whole thing first and then go back and pick it apart, because sometimes they're going to give you confusing information, but the question isn't even needing it. All right, this one says, what are the coordinates of the roots and vertex of y equals x squared minus 2x minus 15? Okay, remember, roots are x-intercepts. The vertex, though, to get that, we have to put this in vertex form. We did the math on this. Even yesterday, we did a couple problems like this. So it's the stuff we've been doing recently. There's 2 steps here. To find the vertex, remember, the vertex is your h and your k. Okay? So to get h, we had to do the little formula, which x is h in this occasion, it's the negative b over 2a. And then to get the k, you'll plug this value in back to the equation to get k. So remember, a is in front of the x squared, b is in front of the x, which I wish it wasn't written the way it is, and c is over here. B is a negative 2. I'm sorry that it broke it down. It just finished the sentence on the next line. So see how B is negative 2? So when we put negative 2 here, don't forget there was already a negative. Oh, sorry, scoot over a little bit. And then it's over 2A. A, what number's here even if you don't see it? Yeah. So 2 times 1 is on bottom. What happens when you have a negative of a negative? It becomes a positive. So negative 2 is positive 2. And what's 2 times 1? 2. So what's 2 divided by 2? 1. So our H is 1. Okay? That's the part we just found. K, remember, K is like your Y. So that's what we're kind of looking for here in the equation. So we've got y, which is the same as our k. We're going to plug this in for x. So we've got 1 squared instead of x squared minus 2 times 1 minus 15. Well, what's 1 squared? 1 times 1. 1. What's 2 times 1? Okay, so 1 minus 2, negative 1. And then we have negative 1 minus 15, so same sign, add and keep. That's going to be a negative 16, right? So that's what goes here. So that's our vertex. So that's part of our answer. And it also wants the roots. Now remember, roots are like solutions. Basically, they're saying solve for x. So when you have the solutions, that's where y is 0. So I'm rewriting this equation, x squared minus 2x minus 15. But instead of making it equal to y, I'm going to make it equal to 0 because that's how I get my solutions. Remember, the solutions are where it crosses the x-axis, and that's where y is 0. We talked about that on a couple of the other problems. Now this one's actually going to factor. So we don't have to do quadratic formula on this one. So remember to last unit, we've been factoring for 2 units now. Because not just last unit, but we factored the one before. When you have an x squared, that's what you get here is x times x. But what 2 numbers will multiply to give you 15? Yeah. Now technically 1 and 15 are also choices, right? But if you look here, we're going to be subtracting because that's a negative, and we want to get a 2. 1 and 15 are not going to subtract to give me 2, but 3 and 5 are. So specifically we want a negative 2. If I do 5 minus 3, I just get 2. But if I do 3 minus 5, I get negative 2. So that's what tells me which sign is which. Now remember, the reason we set them equal to 0 is so we can solve. So this means that x plus 3 is going to equal 0, and x minus 5 is going to equal 0. How do I solve this one and get what x is? How do I get rid of a plus 3? Yeah. So if I subtract it, I get x equals negative 3. I'm sorry, that's a little bit small there. On this one, how do I get rid of a minus 5? We add it. Basically, when you have the factors, the solution is just going to be the other sign, because on this one, x equals 5. So if you want to write them as points, where you have x equals negative 3 because y was 0, and you have x equals 5 because y was 0. These are our roots, or our solutions. Either way, they could also be written like this. Sorry, that's little. These are the same thing. One's a point, and one is like what x equals, but do you notice that they're the same thing? Because if you have this step, whichever answer you are using, just look down at your answer choices. If they're points, then you'll be using this version. If they're x equals, you'll be using this version. Okay. So sorry, that one part was tiny. All right. Number 8 says, which quadratic function in vertex form can be represented by a graph that has a vertex at -5, 3 and passes through the point 1, -10? All right, so there's two parts to this problem. The key part here is remembering that your vertex is your h and your k. And they asked about it in vertex form. So remember, vertex forms looks like this. And you have this in your notes. If you don't have it memorized, it's okay. So basically, if you're plugging this in for h and k, x minus h, well, what happens when you minus a negative? So it'll look like x plus 5, and then plus k, so plus 3. This is the equation if this is the vertex. Now it says they want it to pass through 1, -10. Before you do this step, I want you to always pause, because look at your answer choices. I know we don't have them here, but when you do, if there's only one answer choice that uses these two pieces right here, then don't bother finding A. It's more work than is always necessary. If when you look at your answer choices, there's more than one choice that has the right numbers here with the right signs, then what you do is you would plug this in as your x and your y and solve for A so you can finish writing this equation. Okay, so maybe you're done at this step. Okay, so always check first. If you've done this step, before you keep going, see if you can narrow down your answer choice to just one with just this step. Save yourself time and effort. Okay, not just on our unit test, but on STAR as well. Okay, now, if, and only if, you don't have only one answer choice that shows the plus 5 and the plus 3 with those signs, then go to this step. Okay, so what you would do is you would keep the same problem, but you're going to plug these in for x and y. So for y, I'm going to write the -10. I still don't know A, that's why I'm doing this. And then for x, I'm going to write 1. Okay? So then we just think about our order of operations. How do I move a plus 3? Just like you told us on the last one, right? So, -10 minus 3, same sign, add and keep. Okay, what's 1 plus 5? Okay, and what's 6 squared, or 6 times 6? Yeah, 36. So I've got a letter times a number. So remember, to get rid of times, you divide. Okay, so this is what our A is. So if you needed it, you could now plug this in here. You would say y equals the -13/36 times x plus 5 squared plus 3. So this might be your answer as well. But see, the thing is, the reason I say always check this one first is because this is the vertex. Okay? Maybe it's the only answer choice with that vertex, and then we didn't even need to know A, because we would be able to look and say, oh, that must be A because it's the only one with that set of numbers here. Okay? Y'all with me? Only do this step if you can't find the answer from just this one. Okay? Y'all know the old adage, work smarter, not harder. No sense in doing the extra step if it's not needed for this one. All right, let's look. Last page on the paper. 2 more questions. All right, number 9. says the graph of a quadratic function r is shown on the grid. What is the solution to r of x equals 0? Okay, this is another one of those. The question's easy, but you got to know what they're asking. Remember when we did function notation, a lot of times you saw f of x, but r of x, remember this is just y. So they're asking you, what's the solution? Remember, solution is another word for x-intercept. So they're basically saying when y is 0, which is the x-axis, what numbers do we have? So we have this one, and we have this one. So if you look, that's -2, -4, -6. So -6, 0 is a solution, or you could have that written as x equals -6. And then right here, let's see, there's 2, 4, 6, 8, 10, 12, 14. You could have 14, 0, or x equals 14 as a solution. These are both right. It wasn't a hard question as long as you know what they're asking. What they're asking didn't really require any work. No algebra, like computations had to be done, right? But the real question is, would you know that asking this question meant where does it cross the x-axis? Okay, so that's the key there, is they're asking you where does it cross the x-axis, and they're expecting you to know that. But they're not saying those words. They're saying it in a different way. All right, last question. All right, it says function p is in the form y equals ax squared plus c. Notice there's no b here. Yeah, I'm fixing to move it up. I think he's still writing. I'm just looking at the equation. Notice there's no b. That means if you were solving this one, you would get to do it with the square roots, which were the easier ones. But that's not what they're asking you to solve. They're not asking you to solve. They're saying if the value of a is less than 0, so that would mean a is negative, right? Less than 0 would be a negative number. And c is more than 0. This would mean c is positive. Which graph could represent this? So remember, and I've got those notes from earlier. We did these notes the very first day. If you look here, when a was negative, notice how it flipped. We talked about that. This is also written down here. A, the function reflects over the x-axis if a is negative. Okay, so that means it's going to be upside down. It's going to look like, yeah, that means b's out, right? Because b, the graph is not flipped. It's the traditional parabola. Okay, but then if c is more than 0, like right here, see how that moves it up? They're calling it C there, but see how it's at the end right here? Sorry, right here. Notice there was no parentheses in this one, so that's why I'm looking at this, not this. So if it's more than 0, that means it goes up, right? So which one of these is the point moved up from 0? Yeah, this one that was moved down, so C would be negative. This one, it didn't move at all. C is 0. It's still touching right at the origin. So A is the only one that's both of these things. Now read this part carefully when you take your test, because everything changes, but we're asking the same type of question. All right? So remember, you have a test tomorrow. You now have the review completed. You need to study. You can use your notes when we take the test. You can use your review. You can use your calculators. You can't use your friends or the internet. Okay? All right. Any questions?